Hello all. The title of this project is HomoMongo. It's homomorphic encryption for geolocalized objects stored into NoSQL databases for the course Distributed Systems. Presented by Dennis Glenn, AJ. Thanks. Introduction. The aim of this project is to set up an environment with NoSQL data to cipher the geolocalized objects stored in MongoDB that uses two crypto technologies in comparison, that is the traditional and homomorphic cryptography. The following IoT resources were utilized to achieve this project. The one marked in asterisk are Composery, Node-RED, JSON, MongoDB. The remainder the researcher can use or add at their own discretion to complete this project. I use Mosquitto telemetry, MQTT, Owntracks to cipher the geolocalized object position and certificate authority. The design of HomoMongo is partitioned into three parts for easy understanding. On the client side, you could choose any suitable API of your choice like RA, Google Map API, or Owntracks. I settle for Owntracks. The Owntracks API publishes to the MQTT Broker server on the internet, and our private MQTT subscribe from it and publish to Node-RED, where it is encrypted and sent to MongoDB, and the user can now access it. In our Dockerized server app section, the MQTT subscribe from Owntracks via the public broker server and then transmit it to Node-RED, where it is encrypted and sent to our IoT cloud. It could be hosted on a Raspberry Pi on your private network or on a public server network like IBM Atlas or Amazon EC2. Client sites. What is a geolocalized object? It's an API that enables us to obtain the position of the device and give the site access to the location, which is represented by latitude and longitude coordinates. Owntracks Clients is an open source project that can be installed on mobile phone to record your current location and keep track of your family and friends. Owntracks publishes location information to a broker like MQTT or via HTTP endpoint. The data published is transferred as JSON. You could be tracking a thermometer taxi or a person using a mobile phone. It is transmitted through a network. Look at this wireless network here to the cloud. And what data are we talking about? JSON. It's a lightweight text-based open standard data interchange format. Why is JSON very important to this project? Is because no SQL systems like MongoDB and even CouchDB uses JSON formats to store data. We dealt with GeoJSON data, which is a collection of geometries and its attributes described using JSON. Look at a sample of how it looks like. The feature collection object has property, which I call, name it, Unimi residence, where I'm staying. Geometry in terms of point are coordinates like your latitude and your longitude. Server apps. MQTT Broker, also known as MQTT Message Server, is responsible for receiving incoming network connections from clients, handling requests to subscribe and publish, and then forwarding those published messages to other subscribers. We have our public client like Owntracks publishing to the open broker on the web, which is mqtt eclipse.org. This is MQTT Broker cluster. It's a server. And then we have our MQTT client in our private network subscribing from the public broker and utilizing it in the private network, sending to other clients and subscribers. OpenSSL is used as toolkit for the transport layer security. We use it to generate certificates and keys and then use them to create a secure connection between Owntracks client and the Mosquitto broker. Node-RED is a browser-based flow editor that uses module-based approach that connects things graphically to define sequence of operation to perform on a data. It is coded in JavaScript and runs on Node.js platform. Why I like it is because of the intensive library of modules, so you don't have to write code all the time. As many things you want to do can be integrated via module to the repository. The runtime is built on Node.js, taking full advantage of its event-driven non-blocking model. The flow is created in JSON, which can be easily imported and exported. Its ability to debug helps a lot. MongoDB, which is the IoT cloud. Our IoT cloud harbors MongoDB, which is a NoSQL document-oriented program that stores data very flexibly. It's developed by MongoDB Incorporation thanks to the open source IoT resources I'm using. I have to give credit to those who made it possible. MongoDB scales horizontally using sharding. When the user chooses a shard key, it determines how the data collection is distributed and splitted over the range. It's an added form of security. Installation of IoT resources. Let me show you briefly how I downloaded and installed the apps. Now, to download Owntracks on my mobile phone, I click on Google Play. To search for it, I type Owntracks. I select it to download now. Now it is downloading. Okay. Within a few minutes, it will be over because it's lightweight. Okay, I'm checking Owntracks map now. In the middle of the screen, can you see a blue dot? Yeah, it represents my coordinate. Can you see Papados campus? Good. I'm downloading Node.js now. I've gone to the website. I'm downloading the installer. I'm downloading Node.js 12.16. It also comes with the npm package. So you don't have to download it again. And after the whole installation, I will go to the command prompt to verify whether Node.js successfully installed. I will run the command prompt as administrator. You can come to the command prompt, see what I type here, node-v, and this is the version 12.16. And also, this is how you verify for npm. Okay, good to go. I went to Python website, python.org. You could see the binaries. You can download any one suitable for your system or for your strategy. So I downloaded Python 3.7 already downloaded. It's a straightforward installation. I also installed Anaconda, and when you do finish, you can come to your command prompt. I'm running it as administrator. To verify whether Python is installed, you can simply type Python, and it's responding. But before I get to this point, I have to set the path to the Python. I went to my system, which is Windows, and this is the procedure. I went to the advanced tab to environment variables, and then I set the path to the Python folder, and then I can now access Python from the command prompt. As for Anaconda, if you also wish, you can set the path to Anaconda, but when you don't want to set the path, you can leave it alone. But you can access Anaconda prompt from this place. You can type Anaconda. Look at the Anaconda prompt. You can run it, and you open it, and you start using your Conda by specifying the commands here. Thank you. Okay, having installed Node.js and npm, you can come to Node-RED website, which I did, and then you open your command prompt and type sudo npm install /g and save pan Node-RED, and then it will install for you. This is a straightforward procedure, and after the installation, you can open the command prompt and type Node-RED to start Node-RED working on your system. I have already installed Node-RED, so I came here and type Node-RED. After this command I show you, it's still opening. It will take a few minutes. The good thing is, after Node-RED has finished loading, you can come here and see your port setting. It's 1880 at your local host. Local host at port this, and that is Node-RED. Good. Okay, for the Mosquitto installation, I went to mosquitto.org. I'm downloading Mosquitto version 1.6.9. After the installation, I will check the Mosquitto folder for the README file. I will open the README file to check for any missing dependencies. The Mosquitto uses OpenSSL to communicate. I'm going to drive C now. Yes, I'm checking for the program files folder. This is the program files folder. This is Mosquitto folder now. I'm inside the Mosquitto folder. I open the README file using my notepad editor. And what am I looking for? I want to look for the link for the website of OpenSSL, which is one of the dependencies. And now I will scroll down and copy the link. Good. Copy. Now I open OpenSSL website. For this project, OpenSSL will be used to generate the certificates and keys. I'm looking for the appropriate package. The 37 MB is the full package, complete package, not needed. The 3 MB contain all the basic required packages. I can download that one and use for the project. And now that I've done that, I install OpenSSL already. So I come to the folder and check, it's there, good to go. In MongoDB Atlas website, I created a username and password, and then it logged me to the console. I selected free. You can use up to 512 megabytes of storage free if you are just using it for experiment. You don't have to pay. The next thing is to create a cluster. The MongoDB is distributed in your cluster. So now I click on it, and then it takes me to my console. Here, the first thing to do is to get your key for your API, for your applications to use. I came here and I copied it and paste it in my notepad, although that is not a good security practice if you are not going to encrypt it or safeguard it outside your computer. Thank you. Summary for part 1. The basic key points covered in part 1 were the design of HomoMongo project as a client, server, and IoT cloud storage system, which utilizes the following IoT resources: Owntracks, Mosquitto, Node-RED, MongoDB, JSON, Certificate Authority, and others. And finally, for part 1, we look briefly at how these IoT resources were installed along with their dependencies for this project. However, the difficulties experienced during part 1 of this project is due to the ongoing lockdown for the pandemic. Progress was very slow. Over 3 months it took to figure out what open source IoT resources to use and get acquainted with, as I have no access to my university lab to get a Raspberry Pi. I also missed the close interaction with my instructors at close quarters. Thank you for watching part 1.